Hello friends, welcome to Sri Ram's. The topic for today's discussion is Biofortification in India. Last month on World Food Day 2020, during a ceremony to mark the 75th anniversary of United Nations Food and Agriculture Organization, Prime Minister Modi noted that common varieties of crops lack key micronutrients that are essential for good health, and thus biofortified varieties were developed to overcome these shortcomings. PM dedicated to the nation 17 recently developed biofortified seed varieties of local and traditional crops, including wheat and paddy rice, that are being made available to Indian farmers. It is aimed as a sustainable and cost-effective solution to alleviate malnutrition and provide nutritional security. What is biofortification and why is it necessary? Biofortification involves augmenting a crop's inherent nutritional value through genetic improvement. 2 billion people, or nearly 1 in 4 individuals, suffer from hidden hunger or vitamin and nutrient deficiencies, resulting in mental impairment, poor health, low productivity, and even death. Children are especially vulnerable to micronutrient deficiencies. Lack of zinc in childhood leads to poor growth and stunting. Vitamin A deficiency can cause night blindness and poor immunity, while iron deficiency leads to poor mental and physical development. Nutritional supplements are one solution, but these are expensive. Scientists explored how to get required nutrients from food itself and came up with the idea of breeding seed varieties naturally high in micronutrients and high-yielding seed varieties, a concept later termed biofortification. How are biofortified varieties made and delivered? The modern biotechnological tools are used for developing biofortified seeds through gene editing and interspecies transfer of genes. It is much easier and quicker than conventional plant breeding methods. The technology is a cost-effective means to alleviate malnutrition. Promotion of biofortified varieties of crops will be done by linking them with several government programs, namely midday meal, Anganwadi, etc., to make India free from malnutrition. Also, it will ensure good income for farmers along with opening new avenues of entrepreneurship for them. But why haven't we achieved food self-sufficiency? The country has no doubt managed to banish starvation, but malnutrition or imbalanced nutrition and undernourishment or inadequate nutrition, more aptly called hidden hunger, still persist. India is lowly placed at 94 among 107 countries, below Bangladesh, Pakistan and Nepal on the Global Hunger Index 2020. The poor ranking is attributed chiefly to the high incidence of wasting or low body weight and stunting, inadequate height, and mortality among children below 5. The world's largest undernourished population, about 194.6 million, is in India. About 38.4% children are stunted and 35.7% underweight. Why is there deficiency of micronutrients in the food consumed by most in India? In India, we depend on cereals heavily. The food supplementation schemes are mostly cereal-based, disregarding the need for a balanced and wholesome diet critical for normal growth and good health. The normal diet of poor households is also dominated by cereals. Consequently, the deficiency of proteins, vitamins, and essential minerals like iron, zinc, and iodine is rampant. Why can't we instead promote consumption of fruits and vegetables? The choices we have are two: either promoting the intake of nutrient-dense food like fruit, vegetables, and non-vegetarian stuff, which the poor can ill afford, or transforming the cereals into wholesome food by injecting protein, vitamins, and minerals into them. The latter, achievable through biofortification, is relatively cost-effective and practical solution. No doubt, cereals can also be made more nutritious by blending or coating them with vitamins, minerals, and proteins, but the biofortified grains capable of producing these nutrients on their own have shown better results. The nutrients in their natural state are absorbed in significantly higher quantities than their manufactured substitutes. This is particularly true of the consumption of vitamin A, iron, and zinc by women and children. Studies have shown more improvement in mobility, work performance, and cognitive functioning on account of consumption of natural nutrients vis-à-vis the synthetic ones. That is the reason for Prime Minister to suggest by advocating the inclusion of biofortified grains in the food supplied through midday meals in schools and Anganwadis. What are some examples of biofortified varieties from India? The government of Bihar state, India's third most populous state with the country's highest rate of stunting, recently committed to rapidly scale up production of zinc wheat seed to reach millions more vulnerable farming families, as zinc deficiency is the major cause of stunting. The Bihar government also established a nutritional village where 475 households will cultivate biofortified crops to help promote these varieties. In 2018, the Indian Council of Agricultural Research established minimum levels of iron and zinc to be bred in national varieties of pearl millet, providing a strong regulatory push for the development of biofortified varieties of pearl millet. Can you give the details of the variety that the Prime Minister released last month? The 17 biofortified strains released by the Prime Minister included a rice variety with a high amount of zinc and 3 varieties of wheat supplemented with protein and iron. Among the core cereals, 3 maize hybrids have a higher content of superior quality proteins like lysine and tryptophan. 2 varieties of finger millet or ragi have additional minerals like calcium, iron, and zinc, while a variety of little millet or kutki excels in its content of iron and zinc. In the case of oil seeds, the variety Pusa Mustard 32 has been modified to reduce its content of harmful erucic acid. The groundnut varieties have been gene edited to augment their oleic acid content. In yams, some varieties have been enriched with zinc, iron, and anthocyanin, which is believed to guard against diabetes, cancer, inflammation, and obesity. Well, that's all for today. I hope you enjoyed today's podcast.